Continuing the discussion of functions, just to recap what we have done so far, we have defined our own functions, and C++ also has lots of libraries which define lots of built-in functions. For example, if you include the CMath header file, it contains the definition of many mathematical functions, trigonometric functions, logarithmic functions, such as arc cos or arcsine, arctan, ceiling to round up, and cosine, exponent, base e, and floating point absolute, floor to round down, log, natural log, log 10, power of this number raised to this number, sine, square root, or 10x, and it has a C assert. It defines the assert function. It actually says that if this condition is true, then keep on doing some task. If you want to look into the details of these header files, you can go to this website, en.cppreference.com, and this header file defines functions to test characters. C float, we have discussed that. C limits, we have discussed that in lots of detail. And C time, it defines the time and date function. I'm going to use that. But first, let's recap that CMath has the sqrt square root function. So in this code, I have run a simple loop going from 0 to 5, 0, 1, 2, 3, 4, 5, and x is less than 6. So in each iteration, the value of x is incremented by 1, and then I'm passing the value of square of x, which is 0, 1, 2, 3, 4, 5, to this square root function. So what is actually going on here is that in this main function, I'm calling another function. So from one function, I can call another function, and I'm passing the value of, let's say, 3. So 3 is passed to the square root function. I do not know how this square root function is actually implemented, and that's the actual utility of using functions, because we really don't need to know how the functions are actually implemented. We just need to know that what their names are, and what arguments they take, or what parameters they take, and whether they actually return any value or not. So square root of 3 is 1.73, and that value is returned wherever this square root function is called. So if this square root function is called at this point, and the value passed here is 3, which is the argument, so wherever this function is called, it's returning the value of 1.73 if the argument or the value of x is 3. So if I run this code, it runs a loop, and the value, 0, the square root of 0 is obviously 0, the square root of 1 is this, the square root of 2 of this, and square root of 3 is 1.73205, and it runs all the way to 5. Because once the value of x is 6 less than 6, that condition becomes false. So this loop will exit. So it's a single line loop. I do not need to put the curly brackets for the for loop, because this for loop ends at the very first semicolon. Let's take another example of this function was actually built-in function. Okay, so if we are making our own functions, which we have done quite a few times, so this is a simple user-defined function. So it has a name, it has a parameter list, and it has a return type, and this function, it just returns the value of x multiplied by itself 3 times. So it just returns the cube of whatever number we have passed. Exactly the same function here is this POW, the power of this thing. So I can just raise the value of x to this power. So it's just a user-defined function, and it takes the argument and it returns some number. So just returning a loop going from while n is not equal to 0. So I'm just taking the input. As long as the user enters the value which is other than 0, it will just keep on running this code and keep on giving the cube of the value which the user has entered. So this n is going to be passed to this function, and this function, whatever, let's say the user pressed 10, so this 10 would be passed to this cube function, and this cube function is defined before the main function. So this 10 would be assigned to this x, and this x is a local variable, and it's going to return 10 into 10 is 100, into 10 that would be 1000. So wherever this code is wherever this function call is made, it's going to return the value of 1000 if the argument is 10. So let's run this code. And let's say if I did 10, the cube of 10 is, I mean, is 1000, 12 is like that, and for example 15 is 3375. If I press 0, so cube of 0 is 0, and this will end the code, because this will keep on running as long as this condition is true. So if n, the value which is given by the user, is not 0, it will keep on running this code. If the value is 0, so it will exit this code. I have declared this value integer n equals to 1, so that, I mean, if I have not declared the value, if I have not initialized the value, it might be possible that n is declared, it might contain some garbage value, and that garbage value might equal 0, so that condition would have been false. So just to make sure that the code runs, we initialize the value to some number which is not 0, so that the code runs. Okay, so let's take another example. In this function, it just returns, it takes 2 arguments, it returns any one of these. So if x is greater than y, it returns x, or if y is greater than x, it will return y. So I mean, it's going to return just one of the numbers. So this is another user defined function, and in this code we have defined the factorial function. So factorial is, as you know, that if I have, for example, 5 factorial, I want to compute 5 factorial. So 5 factorial would be 5 into 4 into 3 into 2 into 1, and this factorial function is also explained in the calculator example, the same, pretty much the same code. And this is a permutation function, so a number of permutations from I think the formula, I've written it in notepad, and that's the formula n factorial divided by n minus k factorial. That will be the total number of permutations. And here the point is that we can call one function from another function. I mean, we have been doing that, the same thing, for many times, that in this main function, this is a main function, and the sign of that we are talking about function is the round brackets. So the main function is actually calling another function, and it is also possible that this is sqrt function, wherever that is implemented, is going to call some other functions, and so on and so forth. Okay, so second last example, let's say if we want to print the date in literal form. Let's say I want to print the date, for example, today is August 14, 2020. So let's say the user enters 8 14 2020. So I'm going to print August for the name of the month. So here, this is the function prototype. So this function prototype, I do not need to even name the variables, even though I can do that, but the function prototype has a semicolon right next to it, and I'm saying to the compiler that this function is defined somewhere else, and it's actually defined here after the main function. So it depends whether you can write the whole definition before the main function, or you can just put the function prototype at the top and define the function later after the main function. So this main function takes the input from the user in 3 numbers, month, day and year, and then it calls the print date function, and it passes the values of month, day and year to this print date function. This is a prototype, and the definition is given here. So that month is assigned to the variable m, day is assigned to variable d, and year, whatever the value is, I mean, this is a local variables, month, day, year, and their values are assigned to whenever the function is called. This year is going to be assigned to whatever value it contains, is going to be assigned to y. So if, I mean, this is a simple condition that if m is less than 1, or m is greater than 12, or d is less than 1, or d is greater than 31, or y is less than 0, so I can just put cout error parameter out of range. I mean, this is the error output. I mean, I could have just done simple cout here. If you do not want to use CERR, you can just use cout. And here I'm just going to use the switch m, and if the value of m is 1, I'm going to print January, and if the value of m is 12, I'm going to print December, and that's it. So if I run this code, let's take the number. For example, the first input was month, day and year. So I'm going to put the month is 8, day is 14, and the year is 2020. So it's going to say August 14, 2020. The last example is this function, which is a Boolean function. It takes an input as an integer and it returns a Boolean type, whether that is true or false. So I mean, this simple function which says that whether this year is, I mean, whatever year the user has entered is a leap year, which is divisible by 4 or divisible by 400. The leap year is used to adjust the calendar because the Earth rotation is not exactly 365 days in around the Sun, so we need to adjust that in the leap years. Add one day as February 29th if the year is 2000 or 2004 or 2008. Actually, year 2000 is the leap year because that is divisible by 400 because that is a something like once in a 1000 or once in a 2000 year adjustment. Okay, so this function, main function, calls this function. We take the input from the user, we pass it and we call that function, and we say that if this, I mean, we are calling this function within their if brackets. So that means that this function is going to be called up with this value, and let's say the user has typed 2000. So 2000 is going to be returned as this condition is going to return true. So wherever this function is called, it's going to be saying true. So if true, is going to say cout and is a leap year, else cout and is not a leap year. So it's just an example of the function which returns the Boolean type. So if I have and okay, so if I press 2000 here and it says 2000 is a leap year, if I press 2003 it says 2003 is not a leap year. So it's just taking the value, and this we can call these functions an if statement because this if statement only runs if the condition is true. So if this condition is not true, then else is going to run, and this function calls up the this function returns the Boolean type.